Have you ever wondered what the try and except keywords are and what they do in Python? In Python, these two keywords are used to handle unexpected situations gracefully and prevent programs from crashing. In this video, you'll learn how to use these keywords to prevent errors and make your program more robust. Let's start with a simple example that shows what happens when a program doesn't handle exceptions properly. We'll write a division program that asks the user to input a numerator, a denominator, and calculates the quotient. Because the input function returns the user's input as strings, we'll cast both inputs to floats to enforce the correct data type. If you'd like to learn more about user input in Python, we've left a link to our video on this topic in the description. Our program will work as expected as long as the user provides valid inputs. However, if the user enters something unexpected, then the program crashes. We can safely assume that, for the average user, the message on the screen is gibberish. An output like this is a poor user experience. To make our program more user-friendly, we need to handle these errors, also known as exceptions, more gracefully. We should let the user know what went wrong and what the user should do to address this issue. This is where the try and except keywords come in. We'll use these keywords to help us manage unexpected exceptions. Under the try statement, we indent the code that might potentially cause an exception. If an exception occurs during the execution of the try block, Python stops executing the try block and moves down to the except block. In the except block, we write code that either addresses the exception or outputs an instruction for the user. If the execution of the try block does not generate an exception, the except block is skipped. Let's implement a try except block in our quotient calculator program to handle invalid user inputs. We start by writing the try keyword above the potentially problematic code and indenting the lines of concern. Then we write the corresponding except keyword on the same level of indentation as the try keyword. Under this keyword, we'll write the code that we want to execute if an exception occurs. In our case, we'll write a simple statement that lets our user know there was an exception and provide clear instructions on how to prevent the error the next time the program is run. Great, let's test the code. Like before, when the user inputs numbers, the program calculates the quotient. However, if the user inputs non-numeric data, the program now handles the exception more gracefully by telling the user that they provided invalid input. That's an improvement, but entering non-numeric input is not the only type of mistake the user can make. For example, if we rerun our program and enter 0 as the denominator, our program outputs the same error message. But the two inputs are numbers, so this error message is confusing. The issue here is different. We attempted to divide 12 by 0, which of course is impossible. This produced an exception, which was handled by our except block, which then printed the error message on the screen. To avoid confusing the user, it would be better if our program could handle the two types of errors, non-numeric data and division by 0, separately. This way, we could print relevant messages based on the error type. Luckily, this is possible. To catch and handle these different types of errors separately, we'll use multiple except blocks and specify the type of error that each block should handle. To determine the type of exception we want to catch, we can reproduce the exception in a separate cell. The error type is given as the first line of the output. When we input a non-numeric value, the exception type is value error. So, this is what we must write in the except statement that handles this exception type. Similarly, to determine the exception type associated with division by 0, let's replicate the error. We find that the exception type is 0 division error. Let's add that to the second except statement and change the message in the block's body to be more informative. Great, let's test our code. Now, if we enter a non-numeric value, our program gently directs the user to input a number. And if we enter 0 as the denominator, our program instructs the user to input a non-zero number. Finally, if the numerator and denominator are valid, the program calculates the quotient. Now that's a much better user experience. We're working on lots more Python explainer videos like this one, so be sure to subscribe so that you don't miss out. If you have any questions or topics you'd like to learn about, let us know in the comments below. We'd love to hear from you. Thanks for watching!